In March of 2025, something happened to Saturn that hadn't happened in over a decade. Its rings vanished, not destroyed, not collided with, not stripped away by some catastrophic event. They simply disappeared from view for anyone looking from Earth. And here's the part that should genuinely concern you. That disappearing act was just a preview, because Saturn's rings really are disappearing permanently, and NASA has the data to prove it. I'm your host. This is Cosmos Unknown. Let's start with the illusion, because it's the easiest part to explain and the most spectacular to watch. Saturn's rings span about 170,000 miles across. That's wide enough to fit nearly 7 Earths side by side. But despite that staggering width, the rings are almost unbelievably thin, likely less than a mile thick in most places. Picture a sheet of paper the size of a football field. That's roughly the proportion we're dealing with. Because Saturn's axis is tilted, and because Saturn takes about 29.5 years to orbit the Sun, the angle at which we view those rings from Earth is constantly changing. Twice during that 29-year orbit, the rings line up perfectly edge-on with our line of sight. And when something that thin turns edge-on toward you across that much distance, it becomes essentially invisible. This is exactly what tricked Galileo Galilei back in 1612. When he first observed Saturn 2 years earlier, he saw what looked like a triple object, a planet with 2 strange companions on either side. He had no idea what he was looking at. Then, in 1612, those companions vanished completely. Galileo never figured out why. It would take another generation of astronomers using better telescopes to realize Saturn had rings at all, and that he'd simply caught them edge-on. The most recent crossing happened in March 2025. The next one won't happen again until 2038. But here's where this gets serious. Because while the rings only appear to vanish from our perspective every 15 years, scientists have discovered something far more permanent happening to them. The rings are actually physically disappearing. The discovery traces back to NASA's Voyager missions in the early 1980s. Voyager 2 spotted something strange in Saturn's upper atmosphere. 3 narrow, dark bands circling the planet at its mid-latitudes. Nobody could explain them at the time. In 1986, NASA scientist Jack Connerly connected those dark bands to the shape of Saturn's magnetic field. His theory, electrically charged ice particles from Saturn's rings were somehow flowing down invisible magnetic field lines and raining directly into the planet's upper atmosphere. It took until 2018 for that theory to be confirmed using infrared observations from the Keck telescope in Hawaii. NASA scientist James Webb and his team found exactly what Connerly had predicted decades earlier. They named the phenomenon ring rain. Here's how it actually works. The tiny particles that make up Saturn's rings are mostly water ice, ranging from microscopic dust to chunks the size of boulders. These particles exist in a delicate balance. Saturn's gravity constantly pulls them inward, while their orbital velocity flings them outward. Most of the time, that balance holds, and the rings stay roughly where they are. But some of these particles get electrically charged, either by ultraviolet light from the sun or by plasma generated when micrometeoroids slam into the rings. Once charged, those particles stop responding purely to gravity and orbital motion. Instead, they become sensitive to Saturn's magnetic field, and Saturn's magnetic field curves inward toward the planet, right at the location of the rings. So these charged ice particles get pulled along invisible magnetic field lines, like marbles rolling down a curved track, funneled directly into Saturn's upper atmosphere. Once there, they vaporize, and the water reacts chemically with the planet's ionosphere. The rings are quite literally raining into the planet they orbit. So how much water are we talking about? According to NASA's research, the ring rain drains enough water to fill an Olympic-sized swimming pool every 30 minutes, every half hour. An entire Olympic pool's worth of ice raining from the rings into Saturn's atmosphere. That number alone, extrapolated forward, suggests the entire ring system could be gone within roughly 300 million years. But that's actually the optimistic estimate, because ring rain isn't the only mechanism at work. NASA's Cassini spacecraft, during its final orbits in 2017, a sequence known as the Grand Finale, flew directly between Saturn and its rings. It detected additional ring material falling directly into Saturn's equator, separate from the ring rain process entirely. When you combine both effects, the picture changes dramatically. According to O'Donoghue's research, Saturn's rings may have less than 100 million years left to exist. That sounds like an enormous amount of time. And on a human scale, it is. But on a geological scale, compared to the 4.5 billion year age of our solar system, that's remarkably short. It means we are witnessing the final 1 or 2% of these rings' total existence. And this leads to an even bigger question that scientists have only recently started to answer. Were Saturn's rings always there, or did something happen to create them? For most of the 20th century, the assumption was that Saturn formed with its rings already in place, leftover debris from the planet's birth 4.5 billion years ago. NASA's Cassini mission changed that assumption completely. During its final close orbits in 2017, Cassini measured Saturn's gravitational field with extraordinary precision, detecting changes down to a fraction of a millimeter per second in its own motion. From that data, scientists could calculate the precise mass of Saturn's rings. And the mass was surprisingly low. Lower mass points to a younger age, because brighter, lower mass rings haven't had enough time to accumulate the dark interplanetary dust that would have contaminated them over billions of years. The conclusion published from that Cassini data: Saturn's rings are likely no older than somewhere between 10 million and 100 million years. From Earth's perspective, that means these rings may have formed sometime during the age of dinosaurs. Saturn itself has existed for 4.5 billion years. Its rings, one of the most iconic, most photographed structures in the entire solar system, might be almost unimaginably young by comparison. So if the rings are young, where did they come from? The leading theory involves a catastrophic collision. Either a comet wandered too close to Saturn and was torn apart by the planet's immense gravity, or an earlier generation of icy moons collided and shattered. New research published in 2026 adds another layer to this story, connecting the rings directly to Saturn's largest moon, Titan. Scientists now believe that Titan itself may have formed from a merger between two smaller, older moons, and that this merger could have triggered a chain reaction throughout the rest of Saturn's moon system. As Titan settled into its current orbit, its gravitational influence may have destabilized other moons closer to the planet, eventually causing some of them to collide. The debris from those collisions didn't just scatter randomly. Most of it eventually clumped back together, forming the moons we see today. Saturn has well over 140 confirmed moons, but some of that debris remained scattered, trapped in orbit around the planet. That scattered debris became the rings. If this theory holds, then Saturn's rings and its largest moon share a single violent origin story, one written in collisions, mergers, and gravitational chaos. There's one more piece to this puzzle, and it came from James Webb Space Telescope observations released in 2026. For decades, scientists had puzzled over an apparent mystery. Saturn's measured rotation rate seemed to be changing over time, even though planets shouldn't simply speed up or slow down their spin on short timescales. Webb's infrared observations finally solved it. The apparent change in rotation wasn't caused by the planet's spin at all. It was caused by Saturn's powerful auroras. The aurora heats the upper atmosphere, generating winds, which in turn create electrical currents, which then power the aurora all over again. A self-sustaining cycle that made ground-based measurements of Saturn's rotation wildly inconsistent for decades. And remarkably, this aurora-driven system connects directly back to the rings. Research published in Nature Communications in 2026 confirmed that Saturn's rings actively feed material into the planet's atmosphere and ionosphere, shaping the very same auroral processes that scientists were trying to understand. The rings aren't just beautiful, they're an active, ongoing part of how Saturn's entire atmospheric system functions. So why is this actually good news? Like I promised at the start. Because watching Saturn's rings disappear slowly over the next 100 million years is giving scientists an unprecedented window into how planetary systems evolve. We've learned that giant ring systems aren't permanent fixtures of planets. We've learned that some of the most iconic structures in our solar system can be geologically young, formed by violent and relatively recent events. We've learned that rings aren't passive decorations. They're actively connected to a planet's magnetic field, atmosphere, and aurora, and we happen to be alive at exactly the right moment in cosmic history to witness it. Earlier civilizations looking up at Saturn with primitive telescopes had no idea the rings even existed. Future civilizations, 100 million years from now, might look at Saturn and see nothing but a bare gas giant, wondering if it ever had rings at all. We're here, right now, watching one of the universe's most spectacular structures slowly rain itself away. This is Cosmos Unknown. If this video changed how you see Saturn, subscribe. Hit the bell. Next time, we go even deeper into the outer solar system, to a moon that scientists believe might be hiding an ocean, and possibly life. I'll see you out there. I'll see you.